Good afternoon, everyone. My name is Kyle Myers, and I am an independent consultant, former FDAer, and for this session, most importantly, a MIDRC investigator and moderator for this session. It's my pleasure to introduce our two speakers for this afternoon who are going to be talking about the challenges of challenges and MIDRC's COVID-X challenge. I'm going to introduce them both together because I want them for them to be able to flow naturally from one presentation to the next. Our first speaker, Lubomir Hadjiyski, is a professor in the Department of Radiology at the University of Michigan. He's authored or co-authored more than 170 publications in peer-reviewed journals and has been the principal investigator on multiple NIH and DoD grants. His research interests include computer-aided diagnosis, artificial intelligence, machine learning, predictive models, image analysis, medical imaging, and observer performance. He has co-organized multiple AAPM, SPIE, and NCI-sponsored grand challenges, is part of MIDRC's Collaborative Research Project 9 and the Grand Challenge Working Group, and is co-organizer of MIDRC's first Grand Challenge on COVID classification, the COVID-X challenge that you'll be hearing about shortly. Secondly, we'll hear from Karen Drukker, who's been involved in research at the University of Chicago for over 20 years. She's involved in many aspects of MIDRC, such as Collaborative Research Project 9 as well, Technology Development Project 3, the Grand Challenge Working Group, the Bias and Diversity Working Group, and other cross-MIDRC working groups and committees. She, along with Lubomir and the Grand Challenge Working Group, co-organized MIDRC's COVID-X Challenge, and she also has previously organized and run multiple grand challenges under the umbrellas of AAPM, NCI, and SPIE. So with that, I'll turn it over to Lubomir, and thank you all for joining us this afternoon.
Hi, Lubomir, you need to unmute.
Sorry, yeah, I'm navigating the controls, I think. Kyle, thank you very much for the kind words and very nice introduction. I'm just going to try to share my screen and start the presentation. Do you see my screen?
Yes, we do. It looks great.
Hi, everybody. I'm very happy that I'm invited actually to be able to present a very interesting and important topic, something that we are doing within MIDRC. We'll be talking about grand challenges within MIDRC and challenges for the grand challenges, as it was introduced by Kyle. This presentation was prepared by both of Sam and me, and we kind of shared a lot of ideas and more or less approaches how to do it more entertaining, hopefully. First of all, I also like to acknowledge and say big thank you to Karen. She really is extremely instrumental within our group to organize challenges, to brainstorm different problems. And certainly, I like to be very grateful for our group, which is MIDRC Collaborative Research Project 9, and also our bigger group, MIDRC Grand Challenge Working Group, for which we'll be talking in a moment. What are grand challenges? Grand challenges provides a platform for friendly competition of different algorithms aiming to solve different specific tasks. In our situation with MIDRC and in medical imaging field, it's an attempt to solve a clinical problem. Now, what is so special about challenges, grand challenges? Actually, the very special thing, as any other competition, is the playing field that everybody is going to be competing more or less in the case of imaging, this is all playing by the same rules. We are going to have a common data set of images prepared for participants to be running their algorithms on this one. They have to report the output in standardized way, and also there will be done uniform performance assessment, and all these separate factors are allowing to do more objective comparisons of different algorithms. This is something that really is a target and very useful feature, especially at the time when we have so many different algorithms, especially related to AI. This one really is giving more playing field to be able to gain useful information what's going on in the field in general. Now, in the Grand Challenge, the very important two entities are the organizers and participants. They really are making the challenge. And let's say for the organizers, they are responsible to create a controlled environment, which means they have to have well-vetted database of images, have to be thought well the training testing paradigm, how to partition the data and have less biased results, the performance evaluation, the scoring method, and reporting structure. On the other hand, participants are the critical part of the Grand Challenge. Challenges will not succeed without group willing to accept the challenge and obviously participate to the end of it. And certainly the recipe for successful challenge lies in the hands of both organizers and participants. Yeah, we can say the phrase build it and they will come. As we can see here, they have to build the baseball field in order the baseball players to come and play. But we can define it after a little thinking, build it so they will come. Basically, it also lies in the hands of organizers to make the challenge in the way that it will be very attractive and useful for the participants and the time the time that they'll spend and achieve good results. Why challenges? One answer is certainly the important answer is advance the field. It motivates groups around the world to dedicate the time and talent towards a defined task. Review approaches that are promising or weaker so others know where to focus effort. Very important point. And maybe one of the most important ones is to foster open science with code depositing. And of course, now we have a challenge quiz. What is the single biggest challenge of challenges? And yeah, potentially I give a moment. And I'm giving the answer. This is the image data. Really, the image data is the one that defines a larger part of the challenge. What topic is going to be, what kind of clinical problem will be related to that specific clinical problem, and how many participants will be able to participate. We can do an interesting, nice analogy. Yeah, data is gold, that's true. But of course, our target here is to be like that, to have the gold already in the bank. Unfortunately, the current situation with our clinical data, we are still at the mining process. We have to collect the data, prepare it, and then potentially put it in the bank. But the reality is that we have a piggy bank actually, because the data sets, even we have really a lot of data at different places, different hospitals, it is not ready to be put in the bank. Actually, it's not ready to be put in one big depository that it's going to serve everybody. And we still are dealing more or less with the situation that we have a piggy bank for us with smaller sets of cases, which usually are partitioned in different disease and smaller numbers. Of course, when we collect the data, and some reasons for this one is we like to have image metadata, clinical data, demographic and patient image lesion labels, expert annotations, to make really, to transfer the images to really a gold place to a bank. And all these things has to really go into our piggy bank and have a larger amount of cases as much as possible over there. And here we have the great incentive, Medical Imaging and Data Resource Center, MIDRC, which is trying to give and help a lot in that direction, really to turn the data from partitioned, disorganized data to have it organized in a large sense in a big depository and try to turn it really to a big data vault or gold in our kind of analogy that we're doing in a moment. Now, coming back to challenges, actually challenges are a very important part of MIDRC. 3 of the 5 technology development projects have ideas and proposals for challenges. Also, 2 of the 12 collaborative research projects have also kind of emphasis and ideas how to do challenges. Basically, really challenges are considered very important part in order, exactly as we discussed, to try to test different approaches, different algorithms on new opportunity, MIDRC data set, and obtain relatively nice, unbiased results. Another very important part from MIDRC is composition of the group that we are working within, our challenge group, MIDRC challenge group. It is composed from different members from different organizations, APM, RSNA, and ACR. And all the members, luckily, we are very lucky to have these people who really had experience conducting challenges in the past. Here we have some summary of challenges, let's say, from APM that started 2015, and more or less we have a number of them. We have RSNA challenges, which also have dedicated a lot of effort in that direction, recognizing the importance of challenges. And certainly ACR, they have also a slightly different angle of challenges also, including some training component, which is very interesting angle. And certainly we are very lucky to have really the people which are more or less very heavily involved in these activities, being part of the Grand Challenge Working Group under MIDRC. Now, what is the process that we thought? We kind of really worked together and we brainstormed how and what to do, how to handle all these different issues, problems, challenges, and really put them in some kind of organized form in order to be able to conduct successful challenges. And we recognize that there are some problems. Usually the most challenges developed from existing static limited sets of images and associated data. This is really what is used to do a challenge. And this is really the normal situation, the one limitation. Challenges are designed based on the limitations of this key ingredient. Of course, with MIDRC, now we have a great chance to make really a huge dent in that direction. We expect, and what is really kind of happening, we are having a larger, well annotated and harmonized data set with sufficient information to do many different experiments inside. But at the same time, since it is a very new kind of entity, the way it works, it goes very fast, the magnitude and expanding nature of MIDRC actually also make data collection for challenges and challenge, because we have to really very carefully think how to deal with a specific time frame and how to of data collection and how to define our goals for a challenge. It's certainly a nice problem to have, but this is also something that we have to think about in the process. Now, we came up with the idea that it's the best way, the best well-organized way is to have test data request form. And we have developed that form because it allows for challenge organizers to collect their thoughts. That's very much true, especially with the so many kind of issues, problems, and ideas that we have. Works through their challenge logistics, which again, it's very kind of unique for different challenges, and identify their challenge needs. That one brought us to create a form, and this is a little example of the form, and Karen is going to talk much more about specifics, how we did it for our first challenge, COVID-19X. But we, I mean, the form is following. We have challenge title, challenge a number of subjects, number of imaging studies, distribution of COVID-19 cases and other disease, reference standard requirements, patient demographics distribution, need to associate clinical data, and timeline. It happened that we had many brainstorming sessions to more or less synthesize the initial ideas for the form, but so far it seems this is kind of operationally working, and you'll hear much more about it from Karen in a moment. And then the big question was what to do next. Okay, within our group we created that form. Then what would be the next step? And we here I'm certainly showing the little bit bigger picture what's going on with the data collection process in MIDRC, and our kind of place where we came up giving that form. It was to Gen 3, but the main kind of pipeline of data collection is the cases from ACR and RSNA and other sources, which are the identified and quality checked cases, are going through Gen 3, and Gen 3 has the very important function. We have a sequestration process, and this is a very unique feature for MIDRC datasets. Some part of the dataset is really hidden, and it will be very secret in order to produce very highly unbiased and less subjective assessment of algorithms. This is very kind of important part. It came from the very beginning of design of that database. And then, of course, this one really is very high quality data, and we recognize that we shouldn't really use that part. The part that we found very useful to it is more or less for the unsequestered part. We can have so-called pre-published data, which is so-called temporarily held data for training and validation and used for challenges. And after we complete the challenge, this data also goes to the open commons, open data commons, in order really to, again, enlarge the valuable data sets for the general public. And basically, yes, we discovered that the most efficient way, after many discussions with different groups, is to submit our form to Gen 3. And they really did a great job to do very balanced and harmonized collection of cases representing the larger collection at this moment, of course, at that time moment collection at MIDRC. And we are very grateful for that part, and you'll hear much more about this one from Karen. And in conclusion, MIDRC will provide an extensive resource of data for a vast array of grant challenges. Initially, MIDRC challenges will be organized by MIDRC investigators, but future MIDRC challenges will be organized by the medical image research community at large. Thank you very much.
Okay. Thank you, Lubomir, for that very informative talk. I'm going to start sharing my screen if I can find my presentation. So I'm going to go into a little bit more detail than Lubomir did, perhaps, getting down in the weeds, although it's still kind of a bird's eye view more than getting down into the weeds. And I would like to start with my acknowledgements, and there will be a much more elaborate, complete list at the end. So I will be describing the COVID-X challenge. This was a COVID classification challenge using portable chest radiographs, and the classification task was to distinguish between COVID positive and negative patients. Now, the first thing to note is that these were all portable chest radiographs, meaning that these patients were sick and sick enough to undergo portable radiography, often when inpatient. So this is actually a difficult task, much more difficult than distinguishing normal versus COVID positive. As figures of merit, we used the area under the ROC curve as main metric, and then we had a log loss as a tiebreaker. Our challenge followed a pretty standard format in that it has 3 phases, one for training, one for validation, and then a final test phase that lasted a few weeks. Rules, terms, and conditions applied, obviously, most of which were pretty straightforward. One was that you had to outperform random guessing in order to win any of the prize money that was generously supplied by SPIE. And another one, in order to win any kind of money, you have to allow MIDRC to make models public on our MIDRC GitHub. More about GitHub later. So this is an overview of my talk. So first of all, in the past, each of the challenge organizers, the main challenge organizers, had been involved in organizing grant challenges, as is previously discussed, but this was our first MIDRC challenge. We followed a slightly different format. So instead of distributing data to the participants for training, testing, validation, and what have you, we went to centralized computing. Now, what does that mean? We used Drukker so that participants had no access whatsoever to the validation and test data. We did not provide a training set. The participants had to provide their own training set, or we provided help for them to build their training sets on MIDRC. More about that in a minute. So the main difference is that having these containerized submissions with trained models submitted to us put an extra burden on us as organizers to run these Drukkers, and but on the other hand, it prevented cheating, which we had observed sometimes in past challenges, where people having access to the data, even though without a reference standard, were inclined to do things that weren't really allowed, such as having a radiologist provide assessments. So this was our first experience with using Drukker, and it resulted in some speed bumps that were all successfully overcome. So we had a leaderboard during the validation phase. This was to promote friendly competition, and the performance in the test phase, though, was not reported back until conclusion of the challenge. And actually, the challenge concluded last week. And so far, we're planning to report back to the challenge participants how they performed early next week. So training cohorts are obviously an important part of a challenge, and we did not provide a data set for participants to download per se, but we provided help to participants to build their own cohorts using our wonderful Gen 3 hosted MIDRC data platform, where here you can go to the exploration tab to build cohorts for download. So one note, however, is that under the imaging studies case demographics, there is this COVID-19 positive flag, which is a case level indicator whether a patient ever tested positive for COVID. So this means that this is not an imaging study level indicator whether or not this particular imaging study, such as the radiograph, was acquired while a patient was positive. Now you can, in the portal, build cohorts that filter by a time elapsed between a COVID test and the imaging, so that you do here, where you have a days from study to negative COVID test and days to study from positive COVID test. So this is very, very useful for cohort building if you want to know the specific status of an imaging exam. However, this is still a little bit of a work in progress, and the most feel-safe way to access the data is through Jupyter notebooks that allow querying of the data portal, the public-facing side of MIDRC, directly. And we provided a Jupyter notebook based on an example notebook by Gen 3 from Chris Meyer to allow filtering of cases for portable chest radiographs, adults, and within a certain time frame of a COVID test. And we also provided a file manifest that allowed participants to directly download cases from MIDRC. So the downside of file manifest is that it's a static snapshot of cases that were available at the time we run the notebook. The upside is that participants didn't have to mess with running anything themselves. So the validation and test data are a different story. However, like Lubomir said, these are pre-published data. So meaning they're still secret. They have not been released to the public yet. And so these are, we were looking for portable x-rays of adult patients, and we wanted the distributions to follow the US Census distributions for sex, race, and ethnicity, and the CDC distribution for age of COVID cases. We were also looking for a 50% COVID positivity rate. And this was mainly done to ensure sufficient statistical power of our challenge. And a very important point was that we did not want the presence of any type of medical device, such as breathing tubes, EKG leads, etc., to be a dead giveaway for the presence of COVID. Because we all know that if all your COVID positive cases have breathing tubes and none of your COVID negative cases do, your AI will learn how to recognize breathing tubes instead of learning how to recognize COVID. So this was an important point that we had to keep in mind. So in order for this to all be implemented, Ben Beers made this a very nice interface to annotate, to allow one of our radiologists, Carol Wu, to annotate for the presence of medical devices. Up to 15 devices were annotated for. And she also indicated a likelihood of the presence of COVID. And this is for us to do post hoc analyses and compare the submitted models to her radiologist benchmark performance. So this is how then it was done, in that we used task-based sampling for our data set to match our specified target demographics. Like I said, we wanted to use the US Census distribution and the CDC distributions. So this is a method that draws a subset from the pipeline of incoming cases to suit our needs for this challenge. And from that then, after the fact, after we manually annotated, or Carol annotated for medical devices, we had to separate the data into a test set and a validation set, so that the distributions from validation set and the test set were were very, very similar. So this is a slide that Lubomir also showed, where we have our incoming pipeline. So I'd like to emphasize that, we hope we're getting this in. This is our incoming batch. That's what we were hoping for. But in reality, it looks more like this. So in the end, after we go through all our quality assurance, our annotation for devices, task-based sampling, we end up with this. It's a pretty, maybe the bucket is a little smaller than what we'd hoped for, but the apples in there are very, very beautiful. So this is an overview of our final test and validation split. We had 110 cases with a single radiograph per patient, 110 for validation and 224 for testing. And this is an example here. I know it's a little small, but this is the COVID positive and negative cases are on the y-axis, and on the x-axis is the yes or no medical device present. So here we see that overall, 39% of the COVID negative cases had a medical device present, and 40% of the COVID positive patients had a medical device present. So this is after we go through all our stratification test-based sampling. And obviously we ensured that all the other distributions for age and gender and everything matched too. Okay, so now that we have our data, we go on to the challenge platform, and I don't really have going too much detail here, but this is the challenge platform developed on the MIDRC platform. And the users, what was very important for the users is, you can see there's it's a pretty intuitive layout, but important for the users is the forum that users can use to post their questions. And we had this public so that questions posed by one user would benefit, or answers would benefit everybody. And we also made a lot of tutorials. As you can see here, there's a tutorial page. There were standard tutorials that already existed on Docker installation, using Docker, and then MIDRC specific tutorials on downloading data and general cohort building at our public facing side of MIDRC. And we made a special demo with 3 YouTube videos. Now these YouTube videos are not on the general MIDRC YouTube channel, but on a special challenge channel. So here, this is one example where we have a video to how to practice. You know, we had practice data for people that, you know, try to build a Docker image and submit it and to the platform and see if they got it up and running. So sorry, but not sorry. The results of the COVID-X challenge will be presented at the upcoming RSNA annual meeting. So I'm not going to go into detail about any of that right now. And looking ahead, we are currently working on organizing our second MIDRC challenge, which will be a COVID severity challenge. And we're maintaining a portfolio of many potential future challenges. So yes, please visit MIDRC at the RSNA annual meeting, where we also have a crowdsourcing annotation event. So if you want to show off your annotation, COVID annotation skills, COVID severity, please come and visit us at the RSNA. And here is my more complete acknowledgements page. I really hope I did not leave anybody out. If so, let me know. And here's more things get to know about MIDRC, and I'm pretty sure lots of this was already in the chat. But yes, that's it. Thank you very much for your attention.
Thank you so much, Karen, and thank you, Lubomir. It's obviously a ton of work doing this, so we appreciate all that you're doing. You sure left us hanging. Way to tell us we got to wait for the punchline to RSNA to see how this all comes out. How exciting. And thank you to all the folks who participate in a challenge like this, because we know it's a lot of work and you gain a lot yourselves, but also really teach all of us about the state of the art when it comes to the state of the science. And in this case, we're all quite interested in seeing what we learn about just how accurate algorithms can be in this really important task of discriminating patients with and without COVID from chest X-rays. So you mentioned that the data, you know, is large and growing on the MIDRC website. How did you address, you know, when you started the challenge and you're thinking around the fact that data would continue to get added to the public data set while the challenge was underway? That's a bit different from other challenges you've been involved in. So tell us a little more about how you addressed that reality for MIDRC's data set.
Yeah, Karen, if you want, go ahead.
No, you can go ahead. That's fine.
Well, that was, again, as we briefly discussed, or at least in the presentation, it was a good problem to have. I mean, the biggest problem is when you don't have data. Here, suddenly, we were faced with a new situation. We have suddenly a lot of data, but also it is changing very fast. And we have to come to recognition, to somehow we have to realize realization of that fact, and then we have to come with some solutions how to do it and how to really do the practical approach for that challenge. And also, of course, the COVID is a very special situation, maybe other disease, but COVID specifically, it's also changing itself. At the beginning of the disease, there was no vaccine. Later on, there was a vaccine. There were different strains of the disease. And it was very kind of additional complicated factors that are complicating the entire thinking how to do fair and square challenge, let's say.
Right.
The way we approached it was really, we decided that we are going to try to put more or less a threshold at the time when we started thinking and deciding on the challenge, and specifically clearly explain that, okay, these are the limitations, these are the data set that we have, and we are trying to really do, as Karen showed very nicely, harmonization of the data based on the content of the data. I mean, the demographics of the data, the disease, and as much we try to balance these factors between the validation and test set. That was the best, again, discussion within the group. That was a very complex problem, but at least we thought we shouldn't do specific bias between validation and test set. And hopefully if the people were using the training set, again, the training set was bigger, but that was some kind of representation to some extent of the training set. But that's, again, different people can do different, as we heard from Karen. The rules were that they can use our data like hell, but they're not prohibited by using their private data sets. But more or less, yeah, that was kind of one approach we, at this moment, we decided to deal with that issue.
Question in the middle of that, Lubomir, when you say it was changing fast, could you tell people, you know, something around the numbers that you were seeing? Do you remember? I know that's maybe you don't have it on the top of your head. You were saying the data set was changing
Maybe
fast.
Karen can help here, but I would say the initial numbers were probably the initial stage of disease, and then potentially the people took speed also and started getting more of the new disease. Right. But Karen maybe would know.
I don't think we have specific numbers in mind, but the the public-facing side of MIDRC grows, you know, on a regular basis. There are many new cases released. Now, this does not necessarily mean that they're all new cases. Some of the cases that are being published now are still from 2020 because of the extensive curation and quality assurance that takes place. It's not just ingested and then just dumped out there. It undergoes a whole process of harmonization. For example, there's a lot of work that goes on behind the scenes. So a data shift is not really avoidable between training set, but what we did was for the test and validation set to try to ensure that the distributions were similar so that the participants got a realistic idea of their performance during the validation phase. And in the validation phase, they were allowed a limited number of submissions, but it was to, you know, have them get an idea of their model's performance and to kind of get the competition going between different participants.
And I see in the chat that Emily has made sure that people are aware that we're still, of course, collecting new data donations from MIDRC. So just because we've done this challenge doesn't mean we don't need any more COVID cases from chest x-rays, right? You want to speak to that?
Correct. Yes, we are also interested in other, you know, imaging modalities now that our focus, MIDRC's focus will also include long COVID. So there's more angiography, brain imaging, things like that will be definitely of interest as well. But chest x-rays are, you know, the bread and butter of COVID diagnosis so far. Great.
I think it was Lubomir, you said there's a vast array of possible challenges. So you're already thinking ahead to the next challenge that MIDRC might organize. And you're collecting ideas, you have your own ideas. How do other people suggest things they'd be interested in using the MIDRC data for if you would be able to support it in MIDRC? Is there a portal or a way for them to get in touch?
I mean, that's an excellent question. Again, of course, we started. I mean, something to deal with available that kind of huge opportunity, MIDRC, and available data to try to organize challenge. And certainly, at least in our heads, the logical approach was first of all to understand what we are dealing with, the new concept. As Karen really mentioned, we used the hidden test phase, validation and test phase were hidden. Really, it was Dockerized process, and it was a different kind of pipeline to do all these things. And of course, we had to gain that experience and understand what we are talking about and how to potentially scale what we are talking about. And initially, the idea was really to be within our group. That's why we have quite large, actually, working group, including people from the different subgroups, actually working groups. And also, luckily, we had, as we discussed, people that were heavily involved with challenges at RSNA, ACR, and APM. And that was kind of the test bed for us to understand how to really approach that new kind of paradigm under MIDRC. And certainly the idea is the next challenges. Yeah, we have kind of list, at least right now in the plans, about 6 challenges. Actually, it was a very interesting question. Initially, because again, it was of that dynamics of the data collection, we didn't know what will be the first challenge that you're going to have sufficient cases, because really we had to understand it's not, as we discussed, only number of images. This is also annotation, and annotation is very expensive, and we have experts annotators there. Actually, Adam Landers, he has really, and as he's saying in his words, army of annotators. But again, it happened, it's more difficult to be the captain or the general of this army. It's a little bit dispersed, and all such factors. And that's why we decided, okay, let's put ideas on the list. Let's have number of challenges ready, and let's have readiness. So some of, well, when we have some sufficient data and preparation, like logistic for some of them, we'll start it. And basically, that was the way we thought to approach. And certainly the next step, as we discuss you, the idea is really to open it to the public when everything gets much more organized and we have really more harmonized data and stuff like that. And actually probably Karen can really say a lot about that part. She's very instrumental in that
Yes.
part.
I just wanted to point out that the annotation event that will take place during our RSNA will actually benefit our second challenge, which will be the COVID severity challenge. This will be annotating the public facing side of MIDRC. So anybody, well, we'll ask up front what your qualifications are. So we may not use your annotations if you don't know anything, if you don't know what you're doing. But so that anybody, you will help annotate the public facing side of MIDRC, the COVID positive patients for COVID severity. And there, we'll have tutorials and so on and so forth. So that would be beneficial for a training set. So obviously we're not annotating any of the pre-published data at this point for the challenge, but we will do that in-house with experts. But this annotation event is going to be a big deal, hopefully.
Sure, and while I've got you on the big screen, one of the questions that came in was whether the COVID data is available comes from one site or more than one site. And Emily has answered that
Yes,
there are more
I
than
know.
20 sites. But I want to give you a chance to talk about data diversity and how you're looking at that, and just
yes.
That.
It's obviously a very good question. And we have a MIDRC Device and Diversity Working Group that's actively looking into issues like this, where we're trying to not just have data from large academic centers, for example, but also from smaller hospitals, maybe more rural areas. Of course, it's harder to get collaborations going, and RSNA provided some small grants money to help with that a while back. So we definitely are actively looking into issues like that. So to have a diverse set of clinical contributing sites, for now just in the United States, but hopefully in the future also global.
Right. A great strength of MIDRC. Well, we are at 1:45, the end of our slot. That was fast and wonderful. And I thank both of you for excellent presentations and all the work behind the scenes to pull off this first MIDRC challenge. And we'll all wait at the edge of our seats to see the results being released at RSNA. So thank you so much.
Okay. Thank you.